Bismillahirrahmanirrahim. Assalam O Alikum, dear student. Today we will solve new syllabus KPK Book Foundation Physics SSC 1 Unit number 2 Kinematics. Today we will solve SLO base according to FBISC requirement numerical problems question number 7 to 13 in part 2. Now start today lesson numerical problem question number 7. In question number 7 in 2009 a Bolt created a world record. So in a world record by the running 100 meter in just 9.58 seconds. What is his average speed? Here given data is according to the 2900 in a running record of the world just in 9.58 seconds. Now we can calculate the average speed. So given data distance covered that is equal to S is equal to 100 meter. Now time t is equal to 9.58 seconds. We can find that average speed. So average speed is equal to question mark. Now find the solution as we know that average speed is equal to distance divided by time. Then putting the values average speed is equal to 100 divided by 9.58. So average speed is equal to 10.43 meter per second. This is the average speed in a unit second. So we can calculate this. Next, in numerical problem, question number 8. A runner make a lamp round in 270 meters circular track in 30 seconds. What is average speed and what is average velocity? Here we can find two things. In A part average speed, in B part average velocity. Now first of all write given data. Distance covered S is equal to 270 meter. Time taken T is equal to 30 seconds. So we can find that in A part average speed that is equal to question mark, in B part average velocity that is equal to question mark. Now we can find the part 1. In A part finding the average speed, we know that average speed is equal to distance over time. So we can calculate by putting the values. So average speed is equal to 270 meter divided by 30 seconds. 270 divided by 30 that is equal to 90 meter per second. So the average speed is equal to 90 meter per second. Now for a B part, finding the average velocity. For average velocity, we know that the average velocity is equal to total displacement divided by total time. Here we can putting the values, then as we know that displacement in a circular track is zero because circular track motion displacement is always zero but distance is not zero. On a circular path, body is moving, then point A and become again point A, displacement will be zero, but distance is remaining. So on a circular path, displacement is zero, so distance of the body will be matter. Now we can find the average velocity, but average velocity is equal to total displacement divided by total time. Here displacement is zero, so the average velocity is 0. Now average velocity V average is equal to 0 divided by 30 seconds, that is equal to 0 meter per second. Now numerical problem question number 9. In question number 9, given that speedometer of a car is 20 km per hour in 4 seconds and 32 km per hour in 9 seconds. What is the acceleration of a car in this interval? Here, two intervals are given of speedometer. First is 4 second, that is equal to 20 km per hour. Second interval at 9 second, that is equal to 32 km per hour. Now write the given data. Initial velocity Vi is equal to 20 km per hour. Change into meter per second, then 1 kilo is equal to 1000. Then 20 multiplied by 1000 divided by in 1 hour 3600 seconds. So 20 multiplied by 1000 divided by 3600. So that is equal to 200 divided by 36. That is equal to 5.5 meter per second. Also, we can write the final velocity. Final velocity Vf is equal to 32 km per hour. Change into meter per second. Same process. 32 multiplied by 1000 divided by 3600, that is equal to 8.8 meter per second. Now, initial time Ti is equal to 4 seconds and final time Tf is equal to 9 seconds. Now we can find that acceleration. Acceleration A is equal to question mark. We know that acceleration is equal to rate of change of velocity. Here the given values, rate of change of final velocity minus initial velocity divided by change in time Tf minus Ti. Now putting the values, then we have find two solutions. A is equal to 8.8 minus 5.5 divided by 9 minus 4. Now the acceleration of a body 8.8 minus 5.5 is equal to 3.3 divided by 9 minus 4 is 5. So 3.3 divided by 5 is equal to 0.66 meter per second. So the acceleration is equal to a 0.66 meter per second square. Numerical problem question number 10. In question number 10, given statement, a cyclist increase his speed from 0 to 8 meter per second in 10 seconds. Then move with uniform speed 20 seconds. Here, cyclist move to upward and increase its speed 0 to 8 meter per second in 10 seconds. Then starting to move 30 seconds in a uniform speed. After that, it will be decrease its speed in 20 seconds. The graph of this journey as shows in the form of trapezium. So, calculate the distance covered. First of all, write the given data. Length of first parallel side, that is equal to 30 minus 10 is equal to 20 meter. Now, length of second parallel side 50 minus 0, that is equal to 50 meter. Height of trapezium, that is equal to 8. So we have find the total distance covered S in the form of trapezium. So S is equal to 1 upon 2 sum of parallel side multiplied by height. We know that finding S using the formula distance covered is equal to area under the graph. So area under the graph, we can use that S is equal to area of trapezium. So area of trapezium using the formula. Then as we know that area of trapezium OABC is equal to 1 upon 2 sum of parallel side multiplied by height. Then equation 1 become after putting the value given the answer. So S is equal to 1 upon 2 into 20 plus 50 sum of parallel side multiplied by height is 8 meter per second. So S is equal to 1 upon 2 70 multiplied by 8. Here S is equal to 280 meter. Then distance is covered, the area is equal to its total area. Then S is equal to 280 meter. Now numerical problem question number 10 is complete after question number 11. In question number 11, a given statement, a cyclist is moving with the uniform acceleration of 1.2 meter per second. Here A is equal to 1.2 meter per second. How much time is required to change the velocity from 6 meter per second to 12 meter per second? Here we using the formula of acceleration. What is meant by the acceleration? Acceleration is the rate of change of velocity. Now, first of all, write the given data. In given data, initial velocity Vi is equal to 6 meter per second and final velocity Vf is equal to 12 meter per second. Now, acceleration A is equal to 1.2 meter per second square. Then finding the time. Now using in a solution by putting the first equation of motion. In first equation of motion, Vf is equal to Vi plus At. And also we know that A is equal to, putting the values, Vf is 12 meter per second, Vi 6 meter per second plus acceleration 1.2 meter per second square multiplied by t. Then t is equal to 5 seconds. Next, in numerical problem, question number 12. On motorway, a car is moving with the speed limit is 120 km per hour. By applying the brakes, come to rest. After covering the distance 30 meters, what will be the deceleration of car? First of all, write the given data. Initial velocity Vi is equal to 120 km per hour. Change into meter per second. So kilometer is equal to 1000 and hour is 3600 seconds. Then 120 multiplied by 1000 divided by 3600, initial velocity is 33.33 meter per second. And final velocity body at a rest. So final velocity Vf is equal to 0 meter per second. Distance covered S is equal to 30 meter. We can find the deceleration of a car. A is equal to question mark. Now we can find the acceleration using the third equation of motion. In third equation of motion, 2as is equal to Vf square minus Vi square. Putting the values 2 multiplied by A multiply by 30 is equal to 0 square minus 33.33 whole square. Now calculate the answer. 60a is equal to minus 1110.89. So 60a is equal to minus 1110.89. So a is equal to minus 1110.89 divided by 60. Then final acceleration is equal to a minus 18.5 meter per second square. Negative sign shows that acceleration in the form of deceleration. So deceleration A is equal to minus 18.5 meter per second square. Numerical problem question number 13. In question number 13, a cricket ball goes straight up with the velocity of 40 meter per second. Calculate the maximum height of a ball reached and also in a B part time to reach that maximum height. Here ball is reached at maximum height, then calculate the maximum height with the velocity of 40 meter per second and also calculate the time to reach the height. Now given data, initial velocity Vi is equal to 40 meter per second and final velocity Vf is equal to 0 meter per second. Then acceleration due to gravity G is equal to minus 9.8 meter per second square. Then for upward motion value of G will be negative. Find that maximum height h and time t. First of all, solve a part by using the third equation of motion. 2as is equal to vf square minus vi square. Putting the values, then 2gh is equal to vf square minus vi square. Then h is equal to 81.6 meter. After the calculation, putting the values. Similarly, for our time, now finding the time t, we use the first equation of motion. Vf is equal to Vi plus At. Putting the values, then A is negative, so 0 is equal to 40 minus 10t. Value of G is approximately equal to 10, so negative acceleration minus 10t. 40 is equal to 10t. This implies that time to reach the maximum height is 4 seconds. Best of luck. Subscribe our channel. Take care.